Hi, this is Group 17, and we chose to do our project on pharmaceuticals and personal care products, also known as PPCPs, as a source of water contamination. The Wikipedia page that we chose to edit was Environmental Impact of Pharmaceuticals and Personal Care Products. My name is Lauren DiCrescenzo, and my project partner names are Samira Fanga, Cheryl Jacob, Caitlin Pruitt, and Kelly Zavaleta. First, water contamination by pharmaceuticals is a major environmental issue. However, research is very limited. There are no studies designed to examine the effects of pharmaceutical contaminated drinking water on human health. This started getting attention when there were reports being written by public health professionals in the US which addressed pharmaceutical contamination in waterways. Pharmaceuticals are mostly deposited by human consumption and excretion. U.S. manufacturers have released 271 million pounds of compounds used as drugs into the environment, and an estimated 250 million pounds of pharmaceuticals and contaminants have been deposited by hospitals. There was a U.S. Senate subcommittee designed to address the levels of pharmaceutical contaminants in the U.S. drinking water. This was the first time that pharmaceutical giants were questioned about their waste disposal methods. However, no federal regulations or laws were created as a result of this hearing. Between the years of 1970 and today, more than 3,000 pharmaceutical prescriptions were created, but only 17 prescriptions are screened or tested for in waterways.
Pharmaceuticals in the environment exposure. The Environmental Protection Agency of the U.S. considers the presence of pharmaceuticals and personal care products in the environment as one of the most significant emerging threats to the 21st century. Drugs may enter environmental bodies of water in different ways. Industrial discharge, commercial animal feeding operations, surface applications of manure and biosolids, and wastewater treatment plants that treat residential, commercial, and industrial wastewater. Pharmaceuticals may enter wastewater by excretion of the human body or due to expired or unused medications down the toilet or drain. These products are found to be pseudo-persistent because they enter the environment faster than they can be removed. Effective sewage treatment may prevent significant environmental contamination, but it is not a zero-error solution. Two primary pathways of pharmaceuticals in the environment are excretion, which is the human and livestock excretion of drugs and metabolites following consumption, which can be flows into sewage, septic, or surface runoff pathways to wastewater or biosolids, and direct disposal, which is the disposal of unused pharmaceuticals to a septic tank, sewer, or landfill. Potential sources of entry include patient excretion of the drugs or its metabolites via the sewage system, direct release from wastewater system from manufacturing units, hospital or self-disposal of unused, unwanted, expired drugs via trash or flushing, and terrestrial deposition, for example, sludge application to land, leaching from solid waste landfills, or irrigation with treated or untreated water.
PPCPs are present in water bodies throughout the world, but no studies have shown a direct effect on human health. PPCPs have led to an increase in antibiotic-resistant bacteria. Also, some antidepressants can be found in frogs, slowing their development, while feminization has occurred in male fish when exposed to certain hormones. However, more research is needed to determine the effects on humans of long-term exposure to low levels of PPCPs.
I'm going to talk a minute about the challenges and solutions related to PPCPs in water. The biggest challenge is removal of the PPCPs from ground and surface water. Current water treatment systems were not designed to remove PPCPs, and a 2013 study found that PPCPs such as DEET, nonylphenol, erythromycin, and atrazine were not removed after treatment. Pharmaceuticals such as gemfibrozil, triclocarbon, diclofenac, and THC were still detected exceeding regulation standards after treatment. And gemfibrozil, diclofenac, and flufenamic acid consistently have higher concentrations coming out of treatment than they did going in. So one solution that has been found is ozonation, which is an efficient treatment process for the removal of many PPCPs. Another challenge that we face is allocating resources appropriately. New water treatment technology that will remove the PPCPs is very costly, and it will not completely remove all the PPCPs. Tests to continuously monitor all the chemicals in water would be unreasonable cost-wise, and concentrations of pharmaceuticals in water environments vary from different regions. So one solution to this is to evaluate the risk to human health when allocating these resources. And of course, our first priority is going to be to prevent the PPCPs from entering the water supply. And the solution to this would be through policy and regulation for disposal of PPCPs, as well as consumer education.
My name is Kate, and I just wanted to touch on several scientific limitations regarding the study of PPCPs in the environment and the removal of PPCPs from the environment. First, detection of PPCPs is only as good as the analytical methods currently available. Recent improvement in methods have allowed the detection of most PPCPs in the nanogram per liter range. That's 10 to the negative 9th grams per liter. So it's pretty good, but there's always room for improvement. The most common analytical techniques include gas chromatography for volatile compounds and high-performance liquid chromatography for non-volatile compounds, which are unstable to heat. In the image on the right-hand side of the screen, you can see an example of gas chromatography on the top and high-performance liquid chromatography on the bottom for 12 common pharmaceuticals. Cheryl touched on some of the difficulties in removing PPCPs from wastewater. This is further complicated by the chemical interactions of the substance with the water and the treatment process. Examples of relevant chemical properties include pH, seasonal temperature, and solubility. Finally, more research is needed into what happens to these compounds while inside a wastewater treatment plant. Most studies only record an influent and effluent concentration level.
Policy and Regulation Overview. Public health professionals in the United States began writing reports of pharmaceutical contamination in waterways since the 1970s. Our Stolen Future book by Colburn in 1996 addressed the issue of pharmaceutical contamination in ground, waste, and drinking water. This book looked at poor communities and their water quality. A series of articles published by Associated Press exposed pharmaceutical pollution in 2009. This article looked at the lack of regulation in pharmaceutical industry. They exposed the lack of proper waste disposal by the industry and medical facilities across the nation. A hearing called by the United States Senate Subcommittee on Infrastructure Security, Water Quality, and Transportation Safety in 2009. Policy and regulation. There are no federal regulations limiting pharmaceutical in wastewater or drinking water according to the United States Environmental Protection Agency 2012. The EPA has only reviewed 100 out of 3 1,000 pharmaceutical drugs. Out of those tests, 8 pharmaceuticals were classified as hazardous. Only 17 out of 3,000 drugs are sometimes screened in water. 3 birth control substances and 1 antibiotic were added to the pharmaceutical contaminant list. The Clean Water Act, Safe Drinking Water Act, and the Universal Waste Rule do not include pharmaceutical waste regulation.
We hope you've enjoyed our presentation about pharmaceuticals and personal care products as a source of water contamination. Today we briefly discussed how pharmaceuticals enter the environment, why PPCPs are a problem and what negative health effects they can cause, challenges, limitations, and solutions in this field. And finally, we discussed policies and regulations related to PPCPs. If you have any questions, please feel free to contact us via the Canvas messaging system.